So we've just spoken about carbs. Now it's about fats and oils. Okay. Now, fats and oils, in what way we're concerned with, predominantly we call them lipids. Now, those lipids are predominantly what we call triglycerides, tris and three, and then we've got a glycerol molecule in there, 3 fatty acids and a glycerol. Why we call them fats and why we call them oils is because of the state at which they exist at room temperature. So fats are predominantly the solid at room temperature, so your butters and all of that sort of stuff. Whereas oil, that like the cooking oil that we use, that's like we call it oil because it's in liquid form at room temperature. The great thing about fats and oils is it releases a lot of energy because it has a high degree of what we call oxidation. Now, you don't actually have to know this per se, but it's just good to understand that there's a high degree of oxidation when it comes to fats. That's why when you consume fats versus when you consume carbs, you get more energy being released in fats than you would in carbs. I mean, the process is different in terms of like turning that into energy, depending on what cycle you use and blah, blah, blah. But in general, when you eat fats, you get more energy out of it versus the same number of grams of carbs. Okay, so how do you make fats? Now, as I mentioned, the triglyceride, 1 glycerol and 3 fatty acids. So you can see here, this is the glycerol molecule. These are the 3 fatty acids. They'll come and they'll join together. You can see that water's being lost, and they'll join. Now, the joining here is, you know what this functional group is. You've learnt about it in year 11. Now, these are esters, ester functional groups. That's what holds together the glycerol molecule with the 3 fatty acids that occur here, okay? If you look really closely, that's your carboxyl group and that's your hydroxyl group, and you know that that's required when you have an esterification reaction. So these 3 will come together, and as you notice here, there was release of water. There's 1 water released for every sort of ester functional group that you produce. So here, you're releasing 3 molecules of water. Now, again, very, very similar to what happened when you put monosaccharides together to form like a polysaccharide, right? To form the long carbs, and that is water is lost. And we call that condensation. So we can do the same thing here, right? Even though it's a different functional group that's formed, it's the same process. So you're forming water, which means you call it a condensation reaction. So putting together, making long carbohydrates, condensation. Same thing with fats. Making fats, like the big triglycerides, you're also releasing water, also condensation. Okay, so you might think to yourself, hang on a second, how am I supposed to know all of this stuff? Don't worry about it. The structure for glycerol is in your data book. The fatty acids that you will ever need to know is actually also found in your data book. They've listed all of the fatty acids that they would expect you to be able to work with. You don't have to memorize any of them. If they give you a question in the exam where they give you some sort of weird unknown fatty acid, they'll tell you something about it. Either it's the molecular mass, or they'll probably give you the structure or the structural formula, or just the formula itself. So you don't have to worry about it. So if to make fats, triglycerides, it's a condensation reaction, you're releasing water. Again, to break them down into their individual components, again, the glycerol and your 3 fatty acids, you just put the water back in. So it's the same as what you did for carbs. It's a hydrolysis again. So here, each of these just represents, hey, there's a rest of like the hydrocarbon chain, so you don't have to worry about that. So what you're essentially doing is you're putting water molecules back in here to each of the ester functional groups. Then you're reforming what you had before. Okay, so the OH comes back to here and the H comes back to there, and so that's where each of the atoms are going when they split up again. Okay, so again, you can see a trend now. For biomolecules, carbs or fats, to make them, it's condensation. To break them apart again, it's hydrolysis.